Amphoteric are special substances that can act as either an acid or a base, and aluminium oxides in the middle of the periodic table on period 3 are well known because everything on the left is a metal oxide that turns into reacts with water to make a base, and on the right hand side are the non-metal oxides that react with water to make acids. But here we have the aluminium oxides neutralizing acid, so acting as a base, salt and water, and neutralizing base to create a compound in water. So that's amphoteric. It's acting as either an acid or a base. If substances are giving or taking protons specifically, then they're a special type of amphoteric substance called amphiprotic. Now, the most common one is water, because water can either accept a proton to be a hydronium ion, so it's acting as a base, or it can hydrolyze, it can break off and give the hydrogen ion, so it's acting as an acid. So water is the most common amphoteric, which is also amphiprotic substance. The polyatomic ions that you've been asked to learn, we can also look at those as Bronsted-Lowry acid-base combinations, and most of them down here are actually amphoteric, amphiprotic, specifically amphiprotic actually. But let's look at the top one first. So ammonium, because it can give off that H+, in this direction here, we're actually calling it an acid conjugate base. And then we could also reverse it and call it a base conjugate acid. And the nitrate ions can accept hydrogen ions, become an acid. So that's acting as a base. And so if I've got a proper arrow there, it's strong. And if I've got an equilibrium arrow, they're weak acids and bases. So if you look at most of these polyatomic ions you've asked to learn, carbonate, hydroxide, sulfate, phosphate, and some are weak and some are strong, they all have an intermediate state where they have gained a proton. And from that state, they can go and get another proton, and so be a Bronsted-Lowry base if they start from here. And if they start from here and go over to this side, they're acting as a Bronsted-Lowry acid because they're donating protons, and on the right-hand side, they're accepting protons. Okay, and they're all acting as amphiprotic or amphoteric substances because they are acting as either acids or base, depending on if they go left or right. So, and Bronsted-Lowry acids and bases too. So that's just a different way to look at them and classify them. So just be aware of that.